Now we're going to talk about the string class. You've been using strings since the beginning of the semester, and we've been toying with them more and more recently in some of the homework assignments, but we really haven't talked about them formally, and that's because we hadn't gotten to talk about object-oriented programming. Now that we're talking about that, I can talk to you very clearly about the string class. All right. So first of all, what is a string? A string is a sequence of characters So for example, hello. All right, that's a sequence of characters. And you've been using them since the beginning of the semester. When you do system.out.println, the system.out.println method expects a string as an argument. So that's a string. We're enclosing it in double quotes. But you can also manipulate strings because strings are strings are a class, first of all, and you can create instances of the class formally, like this. String s equals new string hello. So here we are, that's my class. So that's the class. And here we are, this is my variable or object or instance. And this is the initialization method, which is formally called the constructor. And for strings, you can either pass nothing in that case you create something called an empty string, or you can pass an argument. So in this case, I said string s equals new string hello. I can do the exact same thing with the string t, but Java provides a shorthand notation if I just want to put something in double quotes. I can say hello world. Now, if I want, I'll create a final string, W, and I'm not going to initialize that to anything. Now, if I want, I can output the combination of hello and world by saying system.out.println s plus t. So this will output hello space world. So that's pretty wild. All right. So let's continue with this. Remember, we have a string s, which is set to hello, a string t, which is set to world, and a string w, which we haven't set to anything yet. All right. And let's say we were to, I'm going to draw, I actually think what I want to do here is draw a picture for you of what this looks like. So if you remember when we had this idea of arrays, and I said that the thing on the left-hand side, this thing on the left-hand side for arrays wasn't actually the array, it was a reference to the array. And the thing on the right-hand side was actually the array. All right, well, we have a parallel with object-oriented programming. The thing on the left-hand side is not actually the object, it's an object reference. And the thing on the right-hand side is the actual object. Okay, so this is an object reference. This is the object. This is also an object reference. Okay, so if I want to draw a picture right now of what our computer memory looks like, we have something that looks like this. S is an object reference to a string called hello. T is an object reference to a string called world. And W is an object reference, but it hasn't been set to anything yet. All right? So what does this do? What would happen if I said S equals W? I'm sorry, I have that reverse. What if I said W equals S, and then I said system.out.println W? What would you expect to see as output here? So W equals S, system out println W. So what we would expect to see as output is we'd expect to see hello. And why is that? Well, when we say W is equal to S, what we're saying is take the string that S is referring to and have W refer to that string too. So what's going to happen is W is going to refer to the same thing that S refers to, because we're copying this string reference here is getting copied to W. All right? So this works exactly the way we had talked about arrays with arrays. Okay? All right. Let's try another example. Okay? So we've got, maybe we'll do this. We'll grab this and set it back up again. All right. All right. So here's some code. S is equal to hello, all caps. All right, oh, with an exclamation point. W is then set equal to S. And then we say S equals S dot to lower case. And you can kind of guess what that method is going to do. So this isn't a method on string objects. And what it does is it takes the string that's referred to by S and converts all the characters in the string to lowercase. And then we say system out println S, and then we do the same thing, system out println W. Okay, so what's going to happen here? Well, why don't we go through the execution of this and maybe we can understand what's going to happen, okay? You might be expecting to see S and W both print out hello in lowercase, possibly, because we said W equals S here, but that's not actually what happens. So we'll look at what happens right now. So first, S equals hello. So we're going to have this hello all in uppercase with an exclamation point. Okay, so that's step one. Step two, W equals S. Okay, so what that means is that W is no longer a question mark. It's actually going to refer to the same thing that S is referring to right there. So we did that. S equals S to lowercase. Okay, here's the thing. When you say S to lowercase, this creates a new string object. A new string object is created. All right, that's pretty wild. So if a new string object is created, then we're going to, and that string object is going to be all lowercase, we're going to create a new string object that is hello with every character in hello in lowercase. And now S is going to refer to that new string object. Now you'll notice that S got changed,
But W did not. W was referring to the old string object. And so when we print out S here, we're going to get hello, exclamation point. And we print out W, we're going to get hello, exclamation point. Now the reason for this is that there's something special about the way manipulation of strings is done. So manipulation of strings is special. Any operation on a string that alters the string is, or any operation that alters the string creates a new string. This is because strings are something called immutable. Strings are immutable. You are not allowed to change strings. Anytime you try to change the string, you end up creating a new string. Okay? So let's take a look at another example of that. Okay? So we'll set this up again. Here's S, and S refers to hello. Here's T, which refers to world. And here's W, which refers to nothing at the moment. So we say W equals S, and now W is going to refer to hello. And we say S equals S plus space goodbye. Let's clean that up a little bit. Okay, the moment we do that, the moment we say S equals S plus space goodbye, this is altering S. We're changing S, so this is going to create a new string. All right, and the string is going to be the, I guess we'll put it down here, the hello space goodbye string. All right, and when we do this, S no longer refers to hello. S is going to instead, it's going to refer to the hello goodbye string. So we have W referring to hello and S referring to hello goodbye. Really interesting. All right, so anytime you try to change a string, you're going to create a new string. And if you have a multiple object references to the old string and you change one of the object references, only that object reference will change to refer to the new string. Okay, so that's kind of interesting. So all of this is kind of a setup for an understanding that we have to have about the equality in strings. And this is like basically the kind of thing that will bite you in the butt when you're programming with strings, because it seems very natural to want to compare two strings, but if you're not careful, you'll get into trouble. All right. So this is string equality. What does it mean for two strings to be equal? And this is very similar to the idea of what does it mean for two arrays to be equal. So here's a string. String S equals Bob, all lowercase. String T equals Bob, all lowercase. All right? And then string W equals S. All right? Now, what is going to happen when we do this? System.out.println
S equals T. We're saying does S equal T plus S equals W. All right. So essentially what I'm saying is, what does this evaluate to, true or false? And what does this evaluate to, true or false? All right. Well, in order to understand this, what we have to do is draw a diagram. Because at first it would seem it's pretty obvious, you know, S is Bob and T is Bob, so they should be equal. All right, so let's draw a diagram so we can understand that. So here's S, and S refers to a string called Bob. And here's T. T refers to a string that's also called Bob, but it's a different string, but that's okay. They're both called Bob. And then here's W. W refers to the same string that S refers to. So when we compare S to T here, this S to T, what we're comparing is the string reference. Okay, so when we're comparing string references then, we're looking to see, is the thing that S is referring to, is that the same as the thing that T is referring to? And if the answer is yes, then they're considered equal. And the answer is no, they're not considered equal. So in this case, even though S and T both refer to strings called Bob, they're referring to different strings called Bob. So they have different string references. And so this is false. All right? So we had to do the same thing with S and W. Is the thing that S is referring to, the string that S is referring to, is W referring to the same string? Does it have the same reference? And the answer is yes. So this returns true. Why is that a big deal? Well, we would like to know, does S equal T? It's very useful in certain situations to know if two strings are the same. Even if they don't, even if they're different string references, do they refer to the same string character for character? And so there is a way to do that using a special method called equals. So if you say system.out.println S dot equals T, S dot equals W. So if you do that, this is a special method which compares the string S to the string T. So notice that we're comparing the string and not the string reference. Because we're comparing the string and not the string reference, we're able to compare the string character for character. And so this is going to return true. And since S and W refer to the same string, when those two strings are compared character to character, it also returns true. So when you're comparing two strings, you definitely want to use S dot equals or dot equals for whatever string you're working on. I could have also said T dot equals S instead of S dot equals T, or I could have said T dot equals W. All of those are going to return true because character for character, dot equals compares the two strings. So that is very, very important to understand. That's a common gotcha for folks that first start using strings. All right, so watch out for that. It might also be useful to know if one string is bigger than the other. So I can think of a specific situation where that would be useful. When we were, let's say we wanted to sort strings by, sort students by their last name or something like that in alphabetical order. So we want to have some kind of sorting algorithm
So instead of sorting based on integers and comparing based on integers, we want to compare based on strings and string values. And so to understand that, we need to talk about the idea of string comparison. So when we talk about string comparisons, we have to look at a bunch of different strings. So let's compare a couple of strings, okay? So here's hello, and here's hello. And here's hello, and here's Bob. And here's the string hello again with a capital H. And here's string with a lowercase h. Here's string with a lowercase h. And here's string with an E in the middle, right? And what I want to do is I want to know, is this string here, is A, the string A greater than or less than the string, or equal to the string B, all right? So is this string hello greater than, less than, or equal to the string hello? So here we would say they're equal. All right. Is the string hello here greater than the string Bob? Yeah, I would say that hello is greater than Bob. If we looked in the dictionary, we'd find hello later in the dictionary than Bob because H appears after B, so it's greater than. This one's kind of interesting. Hello with a capital H, hello with a lowercase h. If we were looking in the dictionary, we would say that these are equal. And also we'd say that these are equal. We don't really make a distinction between characters. So this is alphabetic. An alphabetic comparison. We're not case sensitive. Okay, but in Java, we don't do comparisons alphabetically. We're actually comparing ASCII characters. And that's how we decide whether one string is bigger than the other. All right, so in the first case with A and B, where we have exactly the same characters, they're equal. In the second case here, where we have an H compared to a B as the first character in each string, well, H has a larger ASCII value in the ASCII table than B. It's really interesting. In fact, let's bring up the ASCII table so we can just see that. I'm still stunned that somebody created a table, a website called ASCII table. I mean, it's like brilliant. This person's probably made so much money doing this. Okay, so we're looking for the letter lowercase b, which has an ASCII value of 98, and lowercase h, which has an ASCII value of 104. So clearly, the hello is bigger than Bob. Now this one's interesting. We start out with a capital H here, and then this hello starts out with a lowercase h. And so since Java uses ASCII values to compare strings, these two strings are not equal. All right? How do we compare them? We have a capital H versus a lowercase h. Well, it turns out a capital H has the ASCII value of 72, and a lowercase h has the ASCII value of 104. So the capital H is smaller than the lowercase h. It's kind of counterintuitive because, you know, a lowercase seems smaller than an uppercase. So you'd think like the capital H would be bigger, but it's actually not. So with an ASCII value here of 72 and an ASCII value here of 104, this is going to be less than this. So we're going to say less than. And then finally, we have this, lowercase h, E-L-L-O versus h, and then the next letter is E. So the ASCII values in this string are not the same as the ASCII values in this string. They differ when we get to the second letter with a capital E. And now we know that uppercase characters have lower ASCII values than lowercase values. So this E, when we compare this E to this E, this has a higher ASCII value than this E. And since that's the case, this is going to be have a larger ASCII value overall than this string. And so we're going to say that this string is greater. Right? That hello is greater. So if we were sorting, we would assign an order to this, where this lowercase hello is bigger than this hello with an uppercase E. All right, so now, is there a method that we can use? And it turns out, yeah, there is a method that we can use to compare to ASCII values. So you can't say this. So I'll write a couple strings here. So let's say we had S, which refers to hello, and then we'll say we have T, which refers to Bob. And then we have W, which refers to hello with the capital H. So if we do this, if we say if S dot compare to T. Now when we do this, it's going to compare the string that S is referring to the string that T is referring to. And if it's greater than 0, it means essentially that hello is greater than Bob. All right? That's what this is basically saying. So the string that S refers to is bigger than the string that T refers to. All right? So this would be returned true if S was bigger than T. So S bigger than T. Else, if S dot compare to T is less than 0, then what we're saying is that S is smaller than T. So the ASCII values in S are smaller than the ASCII values in T. Else, if S dot compare to T is equal to 0, then S equals T. S is the same string, has the same ASCII values as T. Now the way that this compare to works is that we compare the characters at each position in the string. So for example, when we compare S to T, what we're going to do is first we're going to compare the H to the B. And if we find a difference, immediately compare to returns. But let's say we have a V here, and it's HELLO, okay? So if we were to do an S dot compare to V, so S dot compare to V, what would happen is we would first compare the H and S to the H and V, and we'd say, hey, those are the same. So far, S dot compare to V returns 0, but we're not done yet. We're going to compare the E to the E. Those are the same too, so we're not going to return anything. Then we're going to compare the lowercase l to the capital L, and we're going to say, oh, those two aren't the same. And the ASCII value for the lowercase l is larger than the ASCII value for the uppercase L. And therefore, S is bigger than V, and so we'll return a value that's greater than 0. So S dot compared to V will be greater than 0 when it's all done. Okay, so we have a mechanism now to determine if one string is bigger than another using this compare to mechanism. So that's pretty cool. Okay, so what about dealing with, so that takes care of string comparison. And now let's talk about string IO, well, or string input. How does that work? This is really important because you could have some strings that you've created in your program, but what about reading in some strings from the user? It kind of prevented you from doing that so far. But I'd like to remove that restriction now that you're learning how to work with object-oriented programming. So here's how it works. We're going to create a string S, and we're going to use the scanner. So I'll create a scanner. All right, so now I have a scanner. And now I'm going to say maybe enter your name. Maybe we'll change this so it's kind of meaningful here. So let me just write that. Okay, and then we'll say system out print line. Enter name. Okay, and then we're going to say name equals input dot next. Now you might be saying, whoa, wait a second, it's not next int, because if we want to read an int, it was input dot next int. If we want to read a double, it was input dot next double. Sadly, it is just input dot next. It's kind of annoying. All right. So input.next, no next string, just input.next. And now we could say system, whoops, didn't quite spell that correctly. System.out.println, hello, name. Okay, and if we run this, the running of this, if we ran this, you'd see enter name, and I type in Bob, and it would say hello, Bob. Okay, so what's so great about this? Well, it turns out that this next thing is incredibly powerful, and I'll show you why. I think I have an example that demonstrates this. Yeah, okay. So let's say we say instead we're going to gather the first name and the last name, okay? So I'll write some code to do that. So I'm going to create a string first and a string last. And what I want to do is I'm just going to abbreviate system out print line. So that's an abbreviation. That stands for system out print line. Enter, oops. Enter first name, and we'll say enter first and last name, and last name. Okay, now what I could do here is I could say first equals input dot next. And then I'm going to say last equals input dot next. And then maybe I'll do a system out print line of first space last. Okay, so that would be, that would be my system out print line. Okay, so now let's take a look at what the input would look like if we ran this program. We would see something that looks like this.
enter first and last name. Okay, so I enter Bob space Dugan. Okay, now I notice I entered a space here. Okay, because I wanted to separate my first and last name, and then I press enter. All right. Now, this is what's so amazing about next. Here's how next works. Next is going to say, okay, let's look at the input we have here. And next says, this is what next says, and this is so important for you to understand. Skip white space. Read string until next white space. Whoops. Until next white space. And then stop. All right, that's what the next does. It's incredibly powerful, and I want you to understand this. So we're going to skip white space. Well, I just started with the character B, so there's no white space. Read the string until the next white space. So it reads B, O, B, and then it encounters this space. All right, this space is considered white space. So we're going to stop. And so the first string that's returned from next, the string that's returned from this first input dot next is first Bob. Okay. Now we invoke input.next again. So what input.next is going to do is skip white space. Well, this space here is considered white space, so it's going to throw that away and keep throwing away white space until it encounters the beginning of a string. Well, this D is the beginning of the string, so it's going to read in D-U-G-A-N. And when that stops, when we D-U-G-A-N, when we encounter this character here, the enter that the user pressed, that is also considered white space. So I'm just going to note that these are considered white space. So it's space, the return, tab. That's pretty much it for white space. So anything that's a space, an enter, or a tab is considered white space, and next will ignore it wherever it finds it. Okay? So since we skipped the white space to get to the D, and then we read U-G-A-N, and then we encountered white space again, we stop. And so last is going to be D-U-G-A-N, Dugan. Okay? So I want you to take advantage of this next. There's other ways that I could have entered Bob Dugan. I could have done this instead. I could have said Bob, oops. I could have said Bob, new line, Dugan, new line. And now I have some more input that I can do, all right? And so the way the input would work is like this. First, using next, we'll skip the white space. Well, there's no white space to skip at the beginning, so we'll read in B-O-B. So we're going to B-O-B. And then we're going to counter this new line. Well, that new line is considered white space, so we're going to stop reading in the string, and we're going to say the string for first is Bob. All right, now to read in last, what we're going to do is start skipping white space. So we're going to skip this, and then we're going to read in D-U-G-A-N, and then we're going to counter this new line, which is more white space, and that marks the end of the string, and so we're going to read in Dugan. All right. So that
is how you can use next to read in a string. Now, one of the problems that you're going to encounter when you're reading in strings is this. Well, this is actually true of any kind of input, right? How do we know when we're done reading in strings? Like, for example, let's say we wanted to say enter a list of names. Okay, and so maybe I enter Bob, Tim, Kathleen, Mike. Okay, how do we know that we're done with the list of names? Well, we've had this problem before with integers, right? How do you know you're done with a list of integers? Well, we thought about that. We thought about this already. One way we know that we're done with a list of something is we can say beforehand, how many items are you going to give us? So we had list headed by size. We also had ask before iterating. So list headed by size would be, beforehand we ask the user, how many names are you going to give us? 5 or 4. And you go, okay, enter the names. Ask before iterating, the way that would work is you would say, do you have a name to give me? Yes or no. And if the answer was yes, we would say, okay, give us the name. Do you have another name to give me? Yes or no. If the answer was yes, we'd give a name. We just keep repeating that process. The final mechanism we had was something called a sentinel value. Sentinel value was something that was so crazy that you would know that you're done with the list. So for example, we could say enter a list of names, end. If you enter end, that means that you're done with all your names, okay? So Java has a mechanism that's kind of like a sentinel value that's fairly automatic called hasNext, okay? And so I'm going to show you how that works. So you use hasNext with the scanner. Actually, hasNext turns out to be a method associated with the scanner. The scanner itself is actually an object that you can invoke methods on. So when you say like input.next or input.nextInt, you're invoking the nextInt or next method on input. So it turns out that input is actually an object. Crazy. All right, so let's take a look at how we could use this. So we're going to write a little bit of code here. System.out.println, enter list of names. Okay, and we're going to create a string array. Equals new string. Let's make it 10. We'll assume that we're not going to have more than, oh, we'll make it 100. Assume we won't have more than 100 names. Okay, so what we're going to do is we'll create a variable called count, which tells us how many names we've entered so far, and we'll start it at 0. And then we're going to do a while loop. And the while loop works like this. We're going to say while input dot hasNext. And so what that's going to do is if hasNext returns true, more strings are available. And if it returns false, done with strings. There's no more strings to input. All right. And then we're going to say array sub count is equal to input.next. Okay, and so, oh, and we need to increment count. All right, so this will work with the list of names that's up here, but I want to show you what happens to let hasNext know that there aren't any more names to process. I'll show you how that works. All right, so we'll put that down here. All right. So when we're done with our list of names, so we've entered Bob, then Tim, then Kathleen, then Mike. When we're done, right here, we press Enter, and then when we're done, we're going to type two special characters. We're going to type on the keyboard, we're going to type Control and then D. So when you hold the Control character down, so you got to hold that down and then press the D character, this will set hasNext. Let's do it more formally here. So it's going to set input.hasNext. That will be set to false. And the input will stop. So it is sort of like a sentinel. It's like a really weird character that you type from the keyboard. And input.hasNext will be set to false. So this is a way that you can read in lots of information, whether it's strings or it's numbers, integers or doubles, doesn't really matter. And when you're done, you just type Control D, and that means I don't have any more input for you anymore, Java program. And the Java program will stop. Okay. I want to share with you just a few more methods that you're going to find useful with strings. And those are the following. All right. One thing is, if I have, let's say I have a string S. So, okay, we'll call this miscellaneous methods for strings. All right. So here's a few things that you'll find useful. So here's a string, S equals Titanic. All right. Now, I can actually get to any character in string S by using something called char at. So if I say s.char at 3, this will return to me the third character in the string, and we start counting with 0. So it's a little bit like indexing the string as an array. So we have 0, 1, 2, 3, 4, 5, 6. So the s.char at 3 is going to return the letter A. It's going to return the character A. All right, so that's useful. S.length. S.length is going to return the length of the array. So here it's going to return 7. That's how many characters are in the array. But we can also do some cool things to kind of cut up the array and remove parts of it. So for example, Titanic, kind of negative. Why don't we extract a word from Titanic? Let's extract tan from Titanic. So if I did this, system.out.println, that's my shorthand for system.out.println, s dot substring and the way s.substring works is you say a start position. So we're going to start at character 2, and then you specify an end position. We're going to end at character 4. And s.substring will then extract the word tan from Titanic. All right.
Now, there's one other thing that we can do, which is there's a whole bunch of other string methods, which you can Google Java string methods, but one that's particularly useful is the replace one. So what we can do is we can say system out println s.replace the character O with the character, I think we do it in quotes, the character double quotes O with the character, I'm sorry, let's try that again. Let's replace every instance of I with O. So this will return totanic, totanoc. There we go. So you can do a kind of a global, almost like a search and replace. All right, so that's a pretty good overview of the kinds of things that you can do with the string class. And we know that the data associated with string class is basically the string. And then there's all these cool methods that we can use, like compare or equals, or is lowercase. There's also an is uppercase. And we've got char at to get us individual characters if we want to, and length, and substring, and replace. So there's a whole host of things that you can do with strings. All kinds of trouble you can get into. All right, good luck.